Hello and welcome. Today we are talking about permutations and combinations. Permutations and combinations are used to figure out the number of outcomes for a given situation. We're going to use these as a shortcut for finding probability of multiple events happening at the same time, particularly when we are finding the probability of pulling elements from a set where those elements cannot repeat. So an example of a permutation would be figuring out the number of ways that a set of letters can be rearranged. So if I was asked to arrange the first four letters of the alphabet, I would start with A, B, C, D, and then basically just go through the rearrangements until I couldn't come up with any more. So looking at what we have here, there are 24 total arrangements of the first four letters of the alphabet. So obviously we don't want to do this for every single situation where we need to figure out a number of arrangements. So we're going to look at a way to do this more quickly. So the first thing that we need to ask ourselves is how many things do we need to rearrange? So because we are picking four letters, I've marked 4 spaces on the page. The next thing I need to ask myself is how many options do I have for each thing that I choose? For the first letter, I have 4 options because I can use any of the letters A, B, C, or D. For the second letter, I only have 3 options because I'm not allowed to repeat my letters. And then I have 2 options for the third space because again, I would have already used up 2 of my letters in the first 2 spots. And then I only have 1 option for the last letter because at that point I would only have 1 letter left. Then I'll multiply my numbers together to get the total number of arrangements. So if I was asked to find how many ways we could rearrange the first 4 letters of the alphabet, I would say 24 because 4 times 3 times 2 times 1 is 24. To condense the notation even further, whenever I want to multiply a set of numbers that are counting down, I use what's called a factorial, which is noted by the exclamation point. So if I wanted to calculate 5 factorial, I would multiply the numbers from 5 to 1 counting down, which gives me 120. If I wanted to calculate 6 factorial divided by 2 factorial, I'd expand my 2 factorials and then reduce my fraction. So if I wrote out the product of integers from 6 to 1 in my numerator, and then the product of 2 and 1 in the denominator, I notice that the 2 and the 1 are in both parts of the fraction. So to simplify this, I simply multiply 6 times 5 times 4 times 3, which gives me 360. So when we say permutation, we are literally asking for the number of arrangements. So we're doing the same calculation that I did in our first example. The way that we note this is NPR, where N is the total number of elements you have in your set, and R is the number of elements that you need to rearrange. So if I wanted to know how many permutations I could make using the word stop, I would do a permutation of a set of 4 using all 4 elements. So just like in our first example, we would do 4 permutations of 4 by multiplying the integers from 4, counting down. If I instead wanted to know how many permutations I could make using the word canon, I would need to note the fact that the ends repeat. So I would start by doing 6 permutations of 6 because there's 6 letters in the word canon. I would then divide by 3 permutations of 3 because the n's repeat 3 times and we can't tell them apart. From there, we'll just reduce our fraction and multiply 6 times 5 times 4 to get 120. When our elements are arranged in a circle, the calculation for permutations changes ever so slightly. This is because the circle technically doesn't have a set starting or ending point. So depending on where you start counting, you can write the same arrangement in multiple ways. So if I start at the top of the table, president, vice president, secretary, and treasurer is my seating order. But if I were to instead count this as my starting point, vice president, secretary, treasurer, and president would be my order. However, both of those instances are technically the same seating arrangement because the people are sitting in the same physical chairs regardless of where I start counting on the table. So if we were asked to find the number of seating arrangements that we could come up with, we simply calculate the number of permutations and then divide by the number of starting points. So we would take 4 permutations of 4 because we have 4 people to rearrange, and then again divide that by 4 because there's 4 different seats that I could technically count as the starting position. From there we would reduce the fraction and then multiply 3 times 2 times 1 to get 6. Combinations are similar to permutations, only we are looking for a number of smaller sets instead of a number of arrangements. So we're doing a similar thought exercise, only this time the order that we choose our elements doesn't matter. So in practice, the only difference between a permutation and a combination in terms of the way it's calculated is that for a combination, we need to divide out the factorial of the number of elements that we chose. So if I'm going to form a 4-person committee from 10 members, I would be calculating 10 combinations of 4, which means I'm going to take 10 permutations of 4 and divide that by 4 factorial. So we'll multiply 10 times 9 times 8 times 7 and divide that by 4 times 3 times 2 times 1, which will give us 210. Of course, we generally won't be doing these calculations by hand because the numbers can get pretty big. So if I want to use the shortcuts in Desmos, again, the exclamation point is my factorial. For permutations, I type NPR and then put the N and the R in parentheses. And then for combinations, I type NCR and again put the N and the R in parentheses. And that's all we have for this one. I will see you guys next time.